This is an endorser from Germany playing on the gallery.
I think a lot of sax players are, okay, I'm playing the right changes, or I'm playing the, harmonic minor substitution of this chord to that chord, and I know that stuff, but I don't want to think about it. I just want to feel it. So, I was in school, I graduated from Berklee College of Music. We learned all of the theory and all of that, but at a certain point, I want to forget it all. I remember there was a day when my professor in college said, okay, all this stuff that we learned, all this theory that I've taught you, all these things that you think about, now forget it. Now make music and get in the zone. Just have it be what you feel. Have it be what you're just creating. I loved that idea. That was my favorite day in school.
When I play, I chase goosebumps. And if the chord progression is right, and if I'm in the pocket with a song, singing and playing the song that I want to play and sing, life is good.
A lot of people make is a zone, or effortless mastery, or all these different things. What it is you're becoming one with your music. You're becoming on a certain plateau and a certain plane with your music.
When we're all playing together and the groove is exactly where it should be, and we're all going to a place that maybe we've never been before, but it seems like we all go all the time, and it feels transcendent in a way. I can't live without it anymore.
Alright, so one of my favorite things that I get to do is work with just fantastic musicians from all around the world. And helping the musician get in the zone when they're playing, that's what my life's about. So my purpose is to make equipment that makes it easy for you and your students to get in the zone when you're playing, to have that magical experience. And I think that's also why many of us have the mouthpiece disease, right? Why we have a box full of mouthpieces. And it's not always what the sound is coming out at the end of the horn. It's how you feel when you're playing. If you've got equipment that helps you feel free when you're playing, that's you want that, right? And so we're all chasing for that. And so that's my goal is to constantly improve making product that helps musicians have that experience. So the fact that I get to work with some of the world's greatest musicians is just a dream come true for me. And while we have on our endorser form, what's your experience when you feel connected to your music? And it's just fantastic because many of these guys will say stuff like, I asked Chris Potter that, and he's like, well, I'm not a spiritual person at all, but when I'm playing right, I feel connected to the band, and I feel like I'm connected to the audience, and I forget. I'm not in my mind at all, and it's like the music just flows through me. And I'm like, that's the only spirituality I'm really interested in anyway. So you can call it whatever you want. That's what I'm interested in. So I asked some of our endorsers what their experience when they felt connected to the music, and this is what some of them said. All right. So, some of this might be, this next little part might be obvious, but sometimes it's good to state the obvious. And the purpose of the saxophone mouthpiece is to give you the quality or type of sound. The purpose of the saxophone is to tell you what note that is. Now, I'm not saying the saxophone doesn't have a part of that, right? Creating your tone, right? But the classical musician or the jazz musician might both be playing a Selmer Mark 6, right? But they play an extremely different mouthpiece. And that, to me, is what makes the saxophone the best instrument of all the instruments. I'm biased, and I'll just put that out there. It's because there's such a huge range of type of sound and type of expression you can get from the saxophone. More than any other instrument that I've ever heard of. And I'm not saying I don't love other instruments, but the range, right? So, just a very short, explanation or demonstration. Right? The very soft, mellow sound of Harry Allen or Ben Webster. Soprano saxophone mouthpiece. I don't make a classical one yet, but I'm working on it. So the very clean, tight sound of a classical. So, what got me started, I'll give a little bit of the, no, I'll just play this.
The right equipment is what makes everything happen.
It's incredible how you can change yourself as a player, how you can express yourself just as a person through the right equipment. I changed incredibly with a great mouthpiece. I mean, it will change everything.
Yesterday, a student of mine in Manhattan said, "There's something happening when you play that mouthpiece. I really dig it." And I said, "Well, I'll tell you what it is, man. There's a magic in there. Self-expression, freedom. Yeah, man. Unbelievable."
So I was just in Japan, and I got probably one of the best compliments I think I ever got by one of the major shop owners over there. Japan's basically a collection of maybe 5 major Goliath saxophone shops. And so I basically toured around the country with my distributor, and what I heard was that the reason they liked my mouthpieces was because it wasn't just that they sounded better, that they said there was a sense of magic that happened when they play them. And that is my goal, right, is to allow that magic to come out when you play, so that when you experience that, it's my belief that then the audience experiences that. And it just spreads, the magic spreads. So my goal is constantly evolving our product, trying to get more and more magic out of the instrument. So there is no right answer for design, and no two people are going to agree about the same thing, but generally I find there's more or less consensus when a mouthpiece has that kind of magic. And I'm fortunate, I guess in my opinion, to be, I have synesthesia. That means I see sound. So I see different colors and shapes. And so when I'm designing mouthpieces, I know I'm getting close to a good design because I start seeing these like golden hues and these beautiful shapes. I don't know if any of you have seen like Yamamoto, I think is his name. He did these experiments with water drops, and if you put apparently negativity into a drop of water, and then you take a photograph of it, it's like looks really ugly. And then if you put love and care and attention, then you take a picture of the water, it actually looks really beautiful, like a snowflake almost. And it's pretty fascinating, and I feel it's really helpful for me in the design process now, because I have my brain connected with my ears in a way where I can see shapes, designs within a mouthpiece and so forth. And I think I developed that early on by refacing mouthpieces. So very quickly, has to be 25 years ago now, I started off, I was going to college in Colorado, and I was making my way through school buying and selling vintage saxophones. This was kind of before eBay and everything, so I would travel between here, Washington State, and Seattle, between Washington and Colorado, and I'd go to all the pawn shops and stuff, and I'd find vintage Selmers and stuff, and then I'd sell them to Randy Jones over at Tenor Madness, and Sax Alley, and what's that, Horn? USA Horn, and yeah. So I that's how I kind of got started a long time ago, was actually making money buying and selling vintage horns. And at that time, my hero was Dexter Gordon. I was trying to sound like Dexter. And I was playing a 10-star new link, because it was the only way I could try to get the fatness in the sound. And I thought, well, maybe it's just entirely me. Maybe I'm just not as tall as Dexter, or I just don't have the right mouth cavity, or I don't know. But the guy said, well, you need a vintage mouthpiece too, just like you like the vintage horns, get a vintage mouthpiece. So I found an original 7-star Florida Supertone Master, and lo and behold, I sounded that whole level closer to Dexter. And I got really excited. But the thing, it responded like shit. I mean, it was all dinged up and stuff, right? So then I was like, well, what do I do? It has the sound, but it plays like crap, right? And so Randy said, well, what you got to do is you got to find this guy named, Bob Carpenter in Seattle, and you got to send him your mouthpieces and let him fix your mouthpieces. So I sent him my mouthpieces, and then I came back and I was like, holy shit, that's it. I got the sound and it plays great. And so I was good with my hands, and Bob was generous enough, by the distinguished guest here is in the room here, right over here. For 10 years, all through, when I was young, through high school and stuff, I was a bicycle frame building apprentice. So I actually built bicycle frames and jigging by hand, and I did silver soldering and fillet brazing with brass, And this is before all the TIG welding and carbon composite bicycle frames were happening. But I knew how to work with my hands, and so Bob was generous enough just to share his knowledge with me. And he basically, over the phone, just taught me how to reface mouthpieces. And I owe my whole beginnings to Bob. So again, please, it's been 20 some odd, yes.
I'll say a few words when you're done.
Okay. and so Bob helped me, and I just kept learning, and I went a little bit crazy with the mouthpieces. So as I was touring around and I know all the places to get the horns, I started going into these shops and saying, well, do you have any vintage mouthpieces? And they'd be like, well, pulling out drawers, like literally, drawers and drawers and drawers of these vintage Links and Myers and Berg Larsons and Brillharts and everything. And I was like, back then, I'm married now, but my ex-wife was very gracious, because I was like, look, you just got to trust me, because I'm going to spend our entire life savings and I'm going to buy this guy his whole shop. And she was just like, okay. So I literally went in and said, well, how much for everything? And I just started buying literally hundreds and hundreds of vintage mouthpieces. And then with Bob's help, and then just basically I went around and I talked to Ralph Morgan, I talked to everybody, but to be honest, the only truly helpful person was Bob. Because everybody else seemed to have all these weird ideas. You know, about we should never have a mouthpiece bigger than a 5-star. Anything bigger than a 5-star is a mistake, and mouthpieces weren't made to be bigger than a 5-star, and I won't name names or anything, but the ideas that were out there were just kind of, I was like, okay, I better test this stuff out. So what I did is I just lived in my basement, basically taking this link and this good one and this bad one, and then trying to make the bad one sound as good or better than the good one. And so with Bob's help and just scientific method, I started figuring out what makes a Link good, what makes a Berg Larson good, what makes a Brillhart good, and all these different chamber designs and baffle designs and everything. And so I just started documenting all of this. And then at that point, my knowledge started getting bigger, and I started getting inundated with phone calls from all the shops that I was selling saxophones to, and they're all like, Theo, we got this mouthpiece, what is it? Or, you know, how can we make this one sound better? Or, and honestly, I just, literally my day was sitting there picking up the phone, trying to help people, and I couldn't do any work. So I made Saxophone Mouthpiece Heaven. I don't know if any of you remember that website, but I started that website and I put down the histories of all the different mouthpieces. And I literally had thousands of vintage mouthpieces that I had either were original or I had fixed to play as good as an original on there. And at that time I was also working at Gustafson Music in Pennsylvania, in Philadelphia. And I was a horn repair technician. So I was repairing saxophones, and we were selling mouthpieces. And so I started working with guys like Grover Washington Jr., and a lot of the guys who lived in that area would come in, and I'd work on mouthpieces for them. And the mouthpiece business just took off. I mean, it got so busy I had no time to repair saxophones anymore. So I just did Saxophone Mouthpiece Heaven, and sold mouthpieces and did mouthpiece refacing. And so in Philadelphia, all the guys would come through. So at that time, I refaced all the stuff for Joshua Redman, Eric Alexander, Chris Potter, Grover, and just all the guys who would come through. And I did no advertising whatsoever, but word of mouth spread. And then I got so busy with all my mouthpiece refacing and sales of vintage mouthpieces that I had a 4-year backlog, and I was turning away over 95% of the work being offered to me. And so I was, wow, I got to take these designs and start manufacturing so I can actually make these designs that people obviously want, and make them available to other people. So at that time, I was making like custom Myers and custom links and adding baffles and to Myers and links. So I had a whole lineup from very dark all the way up to very bright. And so now I'm going to share with you a little bit about the very, very fundamentals of mouthpiece design from dark to bright, and some of the vintage players who played on them, and our models that fit in that category. Unless anybody has a question about what I've taught. Yes?
Explain the difference in chambers and baffles. I don't even know what a baffle is.
And I will do that right now. Good segue. And we do have a manufacturing video on our website, but I'll let you, on YouTube, but you can watch that anytime. Just go to YouTube, Theo Wanne manufacturing video, and you can read all about our manufacturing processes, which I'll touch again on a little bit. Okay, so mouthpiece knowledge, the basic fundamentals. Okay. All right, so the anatomy of the mouthpiece. So very, very simply here, right? The table, the portion of the mouthpiece that the reed sits flat against and the ligature presses against to hold it on. The facing curve, right here, which is the opening that the reed flaps against, right, to create the sine wave or the sound wave. And it closes off with the tip rail and side rails, and then open, and then that creates your sound wave.
Does the whole reed actually press down against that?
Just this portion.
Well, I mean,
The
so it never presses down against the side rails.
No, it does as it's flapping open and closed. When you blow onto the reed, basically the reed starts vibrating.
And it does flap against it actually pushes down against the side rails.
Yes, it does.
And
it
also the end
completely
rail?
seals off.
And the end rail too as well?
Tip rail, that's right. And the tip rail. So what it does is it closes completely, then
Really?
open. So you basically get little puffs of air that come in, and that creates the sine wave or the sound wave. Right? And the closer you get to this tip rail, the more impact it has on your sound. Right? So as you go farther away, that's why most of your sound that you get comes from about this much. You get the very high harmonics all the way to the bottom end of the horn. And then that's why after this, the saxophone basically tells you which note the sound created here is. Right? So at the very tip here, right, is the baffle, then the floor, and then the chamber. Right? And then these are the inner side walls in here. Right? Now on the outside of the mouthpiece, you've got the beak, like a duck or, like an animal, right? And then the body of the mouthpiece, and then the shank. I was giving a talk in China, this thing, and apparently this translates in Chinese to animal ass or animal butt. Yeah, the whole room, it was like you could have heard a pin drop. They're like, really?
Yeah.
The ass of an animal? And then we explained it, and then they all laughed. But I'll never forget that. That was pretty funny.
Question.
Yes.
I have discussed with people the difference between the chamber of the mouthpiece and the cylinder of the mouthpiece. Do you consider those different?
Yes. So the cylinder you're talking about, I call the bore, right?
Okay.
And that's the section that presses against the saxophone neck, cork of the saxophone neck. Realistically, anything in front of that cork is the chamber, fundamentally. And so the chamber basically is just the inside portion of the mouthpiece.
That is not engaged by the neck.
Yes, correct.
And so,
Which is
that's a
part
pretty-
chamber, part bore.
Yeah.
Yeah.
Okay.
So we've been experimenting now with changing the shape of the bore even, like putting a taper on it or a conic arc there to change the way that the bore connects to the chamber. Because in the past it's just been this straight tube chamber. Nobody's really thought about that. But you're absolutely correct in thinking that whatever's in front of that, right? And if you've ever experimented with the way the air goes into the neck of the saxophone, right? Just that very tip, you know that that has a change, that affects the sound. So, yeah, anything in front realistically is the chamber. Yeah.
So the chamber of from one mouthpiece to another is it's sort of an ambiguous measurement or an area that is hard to draw a line and say, here's the border of where the chamber begins and where the baffle ends, or where the floor ends.
Right. I kind of made up definitions
Uh-huh.
here, which I'll share in just a minute.
Yeah.
Yeah.
Well, I think that the definitions are a really fluid thing for a lot of people. And,
Yes.
And
they contradict.
Yeah, okay, thank you. So
Yes,
there's
they absolutely contradict, yeah.
Good.
That's why I started making nomenclature, and I put on my website kind of like what made the most sense. You know, like when I first came up with my Autolink history, right? There was no such thing as a, early Babbitt. I made up that term. Because how do I distinguish? It was made at the Babbitt factory. I could tell from the shank diameter, right, and the finish work. Right? Obviously, a different group of people were finishing those mouthpieces, and it looks about the same quality, right, as today, right? So I could tell they used a different mold, right? So I just made up some of these terms, and so what is the right answer? Maybe I'm wrong. I'm perfectly fine with being wrong. If we can figure out a better way to say it, but somebody had to come out there and just versus medium versus a flat facing. So the very first, like the old Adolph Sax mouthpieces, the old Autolinks, they all had very small tip openings, but they had very flat and long facings. So that flat and long facing allowed the resistance to be in the mouthpiece. If you put a medium curve on a tiny tip opening mouthpiece, it's just going to, on us, you can't blow hard, it's just going to choke off. You're just going to blow on it, it's going to go. You can't get air in anymore, right? So the way around that is, well, you have to make the very back of the reed vibrate. Well, you get the resistance, and so that's why in the 1930s, 40s, right, the mouthpieces all had small tip openings, right, and long facings with very flat curves, right? Now, though, we've pretty much, most of the mouthpieces on the market have a medium facing length and a medium curve. So you get the resistance through the tip opening, meaning the reed has to go further in this direction when it vibrates, right? So more air can get in, but it also gives you more flexibility in sound. You can growl more, you can bend notes more, you can press more on your jaw and get inflections in the sound. You can do a lot more with the mouthpiece with a bigger tip opening than you can with a small tip opening. All right, mouthpiece baffles. This is probably the number one most important and most impactful part of the entire saxophone mouthpiece configuration. Right? This is what is very different between a classical, well, here, actually you'll hear it here shortly, but this mouthpiece baffle, which goes from about here to about 2 centimeters behind the tip rail, this whole section I'm defining as the baffle. Now, a straight baffle, this is the type of the Adolph Sax mouthpiece, the very early Autolinks, all the very old, mouthpieces. The concept was a big chamber with a straight baffle. Basically, it's just a straight line from the tip rail down into the chamber, right? And what this does is it allows you the air to go in very like bulky. So here's a good way to think about it. When growing up, I had a twin brother, and when my when I was out in the backyard watering, right, with the hose, right, and my brother walked around the corner, and I pointed the hose at him because I wanted to soak him, get him all wet. He's my brother. Nothing happened, right? And the water's going, blah, right? That's because you've got a large volume. I mean, you've got a fixed volume of water going through a large aperture, right? Which means a very thick, basically translates to a thick sound that does not project, right? You stick your finger over that, all of a sudden you get the stream of air and you're shooting that water clear across the room. That's called projection. A high baffle gets you projection, a low baffle gets you thickness. And what that thickness sounds like is this. So both Ben Webster and earlier on I played some Harry Allen, and I worked with him a lot in baffle designs. And basically, the sound does not carry very far. If you're far away, you don't hear it, or it's very soft. It's very, it's a very pretty sound, but it definitely doesn't project at all, right? So in our product line, the darkest mouthpiece is the Ambika, and you can see it's almost a straight baffle, but it's a little higher in the front, so you get a little more projection. So my goal with the Ambika, right, was to get that kind of vintage sound, but with a little more projection. And so here you can hear Mark Hines playing it. Now Mark plays in this kind of style, right? So he accentuates this. And then here's Reggie Padilla.
Aloha, my name is Reggie Padilla. I'm a Theo Wanne endorsing artist from Honolulu, Hawaii, and I play on an Ambika mouthpieces, and they're by far the best mouthpieces I've played in my entire career. They're hauntingly dark, as the description says, and they provide a fat, robust, rich tone with plenty of projection, and it's been, great in my music career.
So these are some of the guys who helped me kind of design a model. So I get to work with some of these guys, and what I do is I send them prototypes and stuff, and then I know they're going for that vintage type of sound, so I just keep designing until I get stuff that they like and I like more and more. So,
Question on that.
Yep.
That cutaway of that mouthpiece there. So you
Yeah.
got a dark section there, then you got, there's like 3 or 4 sections. What does all that mean there?
yeah. So what I did here is an actual straight baffle would officially go from here. I have a straight. Oh, here we go. Yeah. From here. Right. I don't know if you can see this. Maybe this dark. There we go. Here, advertise. From here, right, straight into there, right? So that would be like the vintage auto link that Ben Webster was playing, right? So what I did here is I just raised the beginning portion of the baffle, but keeping the basic, flat design. And the idea was there to like putting your finger over the hose a little bit, right? It adds a little bit of oomph or projection to the sound while keeping the general quality of the sound. And what I did here, as you can see, it's got a very large chamber, which again, I will talk about that after baffles. I'll have a chamber section, right? Rounded inner sidewall. So it's basically got the same general shape as a vintage mouthpiece, but a little more body and projection to the sound because of that.
So I see that dark strip that goes all the way to the, all there. So then what's that lighter part right down from it?
This is just, think of it as a shadow. Yeah, this whole section inside here, this is the bore, this whole section here.
Oh.
This is the chamber, the whole thing. This is just like a shadow.
It's just it's a 3D rendering of
It's
the
a
mouthpiece.
3D.
It's not an actual mouthpiece cut in half. It's just an
Yeah.
extra one. So
Yeah.
they add a little shadowing.
Yeah,
so
we
you can
add
see
the shadow so
contours.
you can, so it looks rounded, right? So think of this as like looking inside a rounded. It goes from here to here. This is the bore, chamber, floor, baffle, basin. Does it make more sense now?
Yep.
Okay.
So in other words, that other part is going like this. It's curving inwards.
Here?
No. Down.
Back here? Oh, this section.
Yeah,
Yes. Yes, it's rounded.
Got
Yes, exactly. Yes.
So I'm curious. So with the design of the metal mouthpieces, the ligature is attached to it.
Yes.
And the rubber mouthpieces are not. I'm just curious. Why aren't the ligatures attached to the rubber mouthpieces?
That's a good question. And the reason is because rubber's not stiff enough, and it bends and pulls up on the table. I learned that from refacing lots and lots of hard rubber latins. Latins actually have slide-on ligatures, and most of the hard rubber latins that came my way, they came to my bench, and they're like, it doesn't play good anymore. And I'm like, hard rubber latin, you use the built-on ligature, right? And they go, right. And I said, what happened is the ligature is pulling up on the table, this section, pulling and warping the table so it's not flat and the reed doesn't sit flat anymore, right? So the reason I don't put a built-on ligature on the hard rubber one is I can't. It doesn't work, just physically, right? It has nothing to do with acoustics, or it's just purely the material won't do it.
Okay.
I mean, I suppose we could put holes like on the side of the body that's really far away from the table and make a special ligature that wrapped all the way around. But that would probably work. But yeah, easier just to make that. The enlightened ligature is the same concept. That's the ligature like this. So what we did with the enlightened ligature is we can. Well, you get the idea, right? Basically, it only touches in 3 parts of the mouthpiece, so it's very free. And then we use our pressure plate too. I could literally talk for hours and hours on the design of this ligature. I bought and had every vintage ligature, every new ligature out there, literally had the table, and I was like, I'm going to make something better than everything. And literally, yeah, Matt remembers this. And we literally, Matt and I just prototyped, and I should put the picture. I'll remember that for the future. I have a picture of like all the rapid prototypes we went through. And we spent a lot of time. I mean, everything from like gemstones, ceramic beads, all kinds of different crazy ideas. Piano wire, stuff that looks like other ligatures on the market now. I see them, I tried that. I know mine's better because I tried that already. And literally, I drove Matt crazy with the R&D process, but I'm like, I'm not stopping until I make something better. So from the pressure plate to the way the thumb screw, I was an Autolink guy, right? So you have these points to hold on to, right? How many people, Dexter Gordon used to carry a pair of pliers around with him when his link got stuck because he couldn't undo his ligature. He used pliers to undo it, right? Well, no more. So we made our little 5-star ligature top, right? And so the concept of the metal ligature, I'll just explain really quick here. You can kind of see there, right? Is it's held on to 2 points here, and there's screws on either side. Now those screws don't fully screw into the mouthpiece. There's actually a dovetail on the end, meaning the very end of the screw is like this shape, like triangular shaped. And that's because when you screw it in and then you pull, when the ligature pushes down on the reed, right, then it pulls the ligature body up. Now the entire ligature body is riding inside here on 2 tiny little surfaces, right? So talk about minimal contact between the ligature body and the mouthpiece. That's the ultimate way to get minimal contact, right? And so what that does is it frees up the reed to be freer in vibration. So the concept of our ligatures with the enlightened ligature, this one, which has 3 points of minimal contact. You can see how narrow it is, right? And then this one, which has only 2, is to basically, we wanted the freest vibrating reed you could get. And then what we have is we have a pressure plate kit that you can buy to then darken it. So you like the Rovner sound? You can still get that with this. You just get a thicker pressure plate. So you get a thicker pressure plate, like a heavy copper pressure plate. It absorbs a lot of the harmonics, gets you more of a core sound, and you get that Rovner classical sound. You want the freest thing you can possibly get that allows all the harmonics to come through? Well, that's what you start off with. And if you want even more harmonics, use our titanium pressure plate or stainless steel pressure plate. You'll get even more buzz in the sound. And you want something in between, use the our vintified pressure plate or the solid silver pressure plate.
Would you be able to make a statement saying that, in general, you think a metal mouthpiece is better than a non-metal one, or vice versa?
No, I'll never make that statement. That's a purely preference. They just get very different type of sound. And you can see on my, there were all these people on Sax on the Web. They were all like saying, mouthpiece material doesn't make a difference and stuff. So I was like, from my experience, that's not true, but let me test this. So Matt and I made the exact same, multiple versions of the exact same mouthpiece out of every mouthpiece we could find. And I have a picture of it on the manufacturing video that's on YouTube. And so what we made is all of the mouthpieces out of every different material, and lo and behold, every material sounded different. You could do double-blind testing. Everybody heard the difference. Everybody had a preference, and the preference was different, but what they heard was the same. Like everybody heard the wood one sounded, well, kind of like dark and pretty, but not very projecting. The hard rubber sounded dark, but really vibrant, right? And the metal sounded more edgy, right? And stainless, and aluminum sounded like dog shit, right? And it's true, right? Nobody liked the aluminum. Yes?
Did you use the same player and the same reed for the test on all those things?
No, we used different players with different reeds.
Well, but
so we did double blind.
Too?
Yes, it does. Now, I'm not saying nothing else matters.
Yeah.
Everything else matters. But what I'm saying is that everybody heard the same differences between the different materials.
We did have one player go through with the same reed and the same ligature and play a bunch of different materials, and then people listened to them, and so it wasn't just like one person playing one type of material, another person playing another type.
Yeah, every person played the whole range with their setup.
Yeah.
And then what they said is, oh, the wood one sounds different from the hard rubber in this way. And then I would go through and play through it on my reed, right, my ligature, my thing, and I would say, oh, the wood one sounds different from the hard rubber. And lo and behold, it was the exact same way. Now at the end, I might say, I like this material better, and the other person said, I like this material better. But the differences, everybody agreed on, 100%. It was actually a very fascinating experience. So does material make a difference? Absolutely. You know, now I know this with horns too. Like our horns use a very high copper content material. It's a little heavier, but it adds a thickness and fullness to the sound. So does the material thickness of a horn, you know, all the vintage guys, you know, does a thin wall Busher sound different than a thick wall Martin? You know, I think so, right? You know, I mean, then does the material make a difference in the sound? Yeah, absolutely. You know, I'm not going to say, though, which one's better. I'll say which one I like better. Yeah. Or if you want a particular sound, type of sound, yeah.
So do hard rubber mouthpieces change over time? I mean, do they deteriorate over time?
Yes and no. If in a perfect controlled environment, no. Is there such a thing as a perfect controlled environment? No. So do they? Yes. It's because of oxidation, sunlight, and heat. So when you see a green mouthpiece, you know, or it's really stinky and you smell the sulfur in there, that's because it was in sunlight or somebody tried to wash it in warm water. Right? So if you have a real hard rubber mouthpiece, keep it out of the sun, keep it away from hot water, wash it in cold water. Right?
Did you try different aluminums? Just for fun? Or, you know, I mean, there's 100 different aluminums.
Yes, that's true, but no, we did not.
Gotcha.
Yes?
You ever made a mouthpiece out of bamboo?
No, I haven't, but I bet it would be really good. But it's very porous, meaning the water goes through it.
Yeah.
So that's why I haven't. So I'm going to keep going. I got this thing. We'll have a general question and answer at the end, and then that way people want to go scurry off and try stuff they can. Okay, the rollover baffle. So the rollover baffle changed everything. This is the bebop, cool jazz, 1950s, the straight ahead. You know, all this stuff came about the same time the rollover baffle came in. And what does that mean? It means you've got a very, very, very short, very high baffle. Right? And what does that do? It means the air spits in quickly and then spreads. And what that does is it adds harmonics to the sound. Right? And a good rollover baffle is the hardest thing to do as a refacer. Would you agree, Bob?
Right.
Yeah, as a refacer.
It's all done right.
Yeah, it's got to be right. And as in manufacturing. Now the reason our mouthpieces, and I'll just state out there, cost so much, is because we had to figure out how to manufacture that so accurately and inside the mouthpiece. It's extremely hard to do. And the mouthpieces we make are probably, we've been told, some of the most difficult to manufacture parts on the planet of anything. So, I literally tried getting manufacturers to make mouthpieces for me, and everybody said they could, and then, like, literally, I'm not kidding, $30,000 later, oh, I can't really do it. That happened in Philadelphia, New York, around the Elkhart area, Los Angeles, San Diego, Seattle, and who figured it out? This guy right here. So that was it took real passion. It took a real passion to make this. And now, in our first model, the Amma mouthpiece, I still had to hand finish the baffle by hand because we couldn't get it exactly right. And now we can do what took us 2 years to do. Then we can do literally in a couple hours now. We're dialing in the manufacturing process so much. So back to the rollover baffle. So, who's famous for playing the rollover baffle? Well, my hero. Yeah. Bob, my two inspirations going in there. And just because it meant so much to me, Robert Martin, who was the saxophone player for most of Frank Zappa's career, recently told me, if Dexter Gordon were with us today, I would bet he'd be playing a Gaia now too, just like him. And I was like, thank you! That's what I set out to do, right? And so you can see the rollover right here. And the shape of the rollover is, I'm showing you it's a round, but it's extremely complex shape. And as Matt will testify, we have spent years and years and years dialing that in for the shape from side to side, what the curve is at the tip, how far back it goes, and then, from side to side of the mouthpiece, like going in and out here, right? What's the shape all around as it goes back? And as I said in the beginning, the sound difference you get is, in this first millimeter, is bigger than probably the entire rest of the mouthpiece and horn combined. Like, you can change everything in like the first millimeter or two behind that tip rail, right? So that's what makes a good mouthpiece refacer very different than someone who's kind of hacking away at a mouthpiece, is the ability to make that rollover like really good, right? And that's, again, I give Bob some kudos for helping me with that. So, so the Gaia has become extremely popular mouthpiece for ours. It's probably that, along with the Durga, our biggest seller. And this is the Autolink style, right? So I set out to make a mouthpiece with the Autolink sound, but even better, based off the feedback I got from all the great players who would come see me. Again, like Joshua Redman, Eric Alexander, Chris Powell, all the link players, right, who would come through. So I had all these vintage links, and I learned how to modify them, and my version is called the Gaia, right? And here's a Russian player. He's not playing, so I won't play the clip, but he's just basically saying how his new album is on the Gaia and how much he loves it.
Yeah. How many otherwise sought after vintage mouthpieces with rollover baffles did you butcher before you had really gotten
Yeah, I just kept at it, and so the end of, for some reason, I have a real natural, I can say it now, I have a real natural talent for mouthpiece refacing. I didn't realize it at the beginning. My brain, I think it's the synesthesia or something, works that way. But I've tried to train, literally spent years training 4 other people. And it's really hard. I mean, it's actually really hard to know how to make a good rollover baffle. And so I think it takes a certain brain type or something. So my brain just works in the way of seeing these shapes. I took some test, they give you for getting into college or something, and while I started embarrassingly on some levels, on the level of shape and recognition, I scored at the highest you can possibly score, off the chart. So my brain works in that way where I can see those shapes. So obviously that's helped me with this. I have a very analog brain, working physically, not digital. Oh, jeez. All right. The step baffle. Step baffle means it's basically like a step. Think of a staircase, right? You basically have a step, right? Like walking down a staircase. Now, the benefit of this is, again, my brother is walking across there, and I'm basically going to move my finger over that hose until I get him soaking wet, right? Now, if you've ever put your hand over a hose like that, the string goes further, 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 and then it starts choking off, until you've completely clogged it. So, how to make the step baffle is actually, it's not just higher is brighter, but it is generally true that higher is brighter until you get to a certain point where it starts clogging. And a lot of the future of mouthpieces, which I'll talk about in a minute, comes from combining these different styles, right? So, who can tell me who made the step baffle famous in the 1970s? Which mouthpiece maker and musician?
Yeah.
Yes, and? Yes. Brecker and Sanborn and Duca. That's right. So, these mouthpieces, are there number one sellers? Is the Durga?
Yeah.
No? More? Yeah. So, honestly, what got me interested in this, because I am a dark mouthpiece, poofy kind of player, and that's what I personally like to play. And to be honest, I started making the Durga because I would hear on the radio back at this time all these smooth jazz players and bright players, but they had these sounds that I just, honestly, I didn't like. I would listen to it and I would go, wow, I can tell this player's got a lot of, like, talent, great ideas, and but I can't listen to it, and I turn it off. Because so what I wanted was a projecting bright mouthpiece where these players could get that altissimo and get that screaming sound, but I wanted some body to the sound as well. And my custom Links and Myers were very popular. What I was doing by hand, basically adding a wedge inside like a bottle. And so what the Durga ended up being was my version of that mouthpiece as a production mouthpiece. Basically, you've got your step baffle, right, into a large chamber, which I'll talk about next, with rounded inner sidewalls like an autoling. So a Michael Brecker model, by Gardella, actually doesn't projection.
The different names for your mouthpieces?
I'll tell you. This is still, believe it or not, this is still the Durga. Sorry, endorser Keith McCully.
Sounds just like a guitar.
off the side, so. All right, well, in case you don't get to hear Andrew New. I have no idea how I did that.
Hey, I'm Andrew New, and I am playing on a Durga Theo Wanne Mouthpiece, and I am so happy here. I actually found a mouthpiece that could do all the things that I wanted to do. I like to be able to play soft. I like to be able to play low. And I like to be able to really be able to dig in on something. And sometimes you want to go into like that pop world. But sometimes you want to play it back a little bit. So anyway, that's the Durga mouthpiece. I'm Andrew New, and I'm really, really happy to be here with this mouthpiece. So stick with it, guys. It's going to be worth it. Check it out.
So each one of your models, you make it in soprano, alto, tenor, blah, blah?
Not everyone, but they're all, you can tell the brightness level by the model name. Ambika, and they're all Hindu goddess names, actually. So the Ambika is actually in Hindu mythology, is actually the goddess, the sweet, loving mother. Come here, son. Everything will be okay, right? And then Gaia is Mother Earth, the one who just takes care of us, right? That's not Hindu, but still divine, the divine feminine, right? And then up to the Durga, right, who's fiery, right? She's the destroyer of the demons, right? And then the male aspect of that is the Shiva, right? So these characteristics are.
So the Durga is the edgiest one you make?
Yes. Yeah. And I'll show you a little more about that in just a minute. So, chambers. So, here's how I definition a chamber. You'll notice that our mouthpieces, I coined the term true large chamber. And the reason I did that is because everybody said this was a medium, this was a large, this was a what, it's different things. So, I'm just saying a true, meaning a real large chamber, means that the chamber is larger than the bore. Just a very simple thing. 1B is bigger than 1A, right? And all the mouthpieces made by Adolph Sax and all the really old mouthpieces at the turn of the century, up until about the I don't know, when did real hardcore's bought? Anyway, 30s? Yeah. But the first ones were all large chambers like this. So a true large chamber, a real large chamber, has a chamber larger than the bore. And there's like Meyer made a large chamber. Well, it wasn't a large chamber. Meyer made a large chamber with the true flex facing, in the very beginning, and then they kept the term large chamber, and it just turned into a slightly bigger medium chamber. So I think this terminology is very clear and simple. If the chamber is bigger than the bore, it's a large chamber, right? And the benefit of a large chamber is you can let the air stream, the transition from this corner point into the chamber goes out. So what it means is the inner sidewalls can be wider, right, than the window opening. This is the window, the opening into the mouthpiece, right? So what that does is if you have your finger over that hose again and you put it over the top, it lets the air stream spread, like spray, right? It's the difference on your windows between the stream and the spray, right? The spray goes, and that creates what we call a thick or a big warm sound, right? As opposed to a focused core sound, right? Core sound would be the stream. And so the chamber allows you to spray the airstream, get it wider, right? And so all the tones that are created will have a thicker type of sound. So the goal, like with the Durga, was to have a projecting high mouthpiece that also spread the sound, right?
You said thick, but that also, I heard people talk about fat.
Yes.
Fat.
Same.
I got it.
Same.
Okay.
Yep.
Slow.
So here's here's actually the very first semi-production mouthpiece I made. Jan Garbert playing the very first Amma that I ever made. It goes down, blah, blah, right? Whenever you get that blah, right, at the bottom end, right, large chamber, particularly on tenor. There are ways around it on alto, soprano, baritone, but on tenor you gotta have that large chamber, in my experience, to get that kind of sound. So next, different types of large chamber. I've experimented a lot now with different ways to get the large chamber. So here's the traditional way of getting a large chamber. This is the autolink style, right? Basically, rounded inner sidewalls which allow the width inside to be greater than the window, right? Spreading out into a big chamber. Again, the big chamber is bigger than the bore, right? That's your traditional large chamber. Another way we do a large chamber on the Durga is we literally put a cutout in. I actually kind of got this idea from Francois Louis. I don't know if you ever saw some of his mouthpieces came through and they would have this small chamber and then this big drop and then back to the medium chamber. And I was like, wow, so I experimented with where to put that, and actually by changing the volume inside here and adding this, we accomplished the same thing as, I should have it on the power lever, which is the exact opposite in the Durga 1. So the Durga 1, the initial Durga, actually had a bump like this inside. It went from a big chamber into a very, very small chamber back into the bore. And what we did is I just changed that, took away and inverted it, and lo and behold, it actually even sounded better while accomplishing the same thing. And I've taken that even further here with what we call a shark gill chamber, and it's because it's like waves, like the gills of a shark, right here, inside. And it's a part of a lot of R&D I've done with boundary layer effect. My brother went to an engineering school called Harvey Mudd College, and one of the professors there was in charge of all of the airflow dynamics. And he and I used to get together and have just amazing conversations, because they would do wind tunnel testing, and I would do mouthpiece testing. And we would discuss the various shapes and which was more effective, what created the laminar flow, what was more efficient with an airstream around an airplane wing or the hull of a boat. And we came to all the exact same conclusions. And as he said that the benefit to my way of doing it was a heck of a lot cheaper than the way that he was doing it. But you can feel it. You play a mouthpiece and then it's efficient with your airstream, then you know you can feel that, right? Well, you can see that with a greater volume of air being able to pass over like the wing of an airplane or through a cylinder or whatever shape you have. Yes?
Do you get more resistance if your bore is smaller than the chamber? Are you going to get some resistance from that? Because the air has to go to the bore, right? If it's bigger here, then it has to go here. And
yes,
come back?
and it depends. Yes and no. Yes and no, because it's like, remember I was saying with your hand on the end of a hose, right? You got your hose here, right? And then if you put your finger over the end of it, depending on how much you block, there's a certain point where the airstream will go faster, and then a certain point where that stream of water starts to die off because you're now clogging it, right? So until you get to that magic point, you don't feel more resistance, you just feel more projection. But then after that, it starts to push back, and then that's why, I've had people say, I've got this great rollover baffle, it should be really bright and play really good, but I don't know, it's not very loud. And I'll take my file in there, take all this baffle material away, and they're like, "What are you doing? I want a bright, edgy mouthpiece." And I hand it back to them, and then all of a sudden it's bright and edgy, and they're like, "What the?" Right? And it's because it was clogging, right? So knowing where that magic point is like, and then what that shape is to get that, is a big part of the type of design, which the way we manufacture now I absolutely love, because we'll take a CAD model and then we can make rapid prototypes, right? All these white mouthpieces you see up here. These are the new versions. The next version that's going to come out will be based on these models.
3D printed.
These are 3D printed, but these designs, right, we have CAD modeled and then we put them on a 3D printer. And a 3D printer is basically like a regular inkjet printer, but it's 3 dimensions, meaning you put one layer down, then another layer, another layer, another layer, and it makes a 3D part, and then you can test it. 3D printing is not accurate enough, and you can't use good materials yet, so it's not a good production tool, but for rapid prototyping and testing ideas, it's a fantastic tool. So if you want to, after I'm done here, try some of the new, like mouthpieces that will be coming out probably next year, you're more than welcome to. And that's these up here.
The white line there where then it bumps up?
Here?
No. Over on the colored thing.
Here?
Yeah, so the white line,
yes.
so that bump up right there, that goes all the way around?
No.
Okay.
No, we've done it all the way around, and I like the sound with it about 3/4 of the way. Yeah. And again, it has to do with the way the air goes into the chamber. And so our designs are no longer just simple designs where it's just a straight tube. This section right here, the way it's designed from side to side, it all makes a big impact in the sound. So a mouthpiece, again, we might remove material and it will get brighter. Other cases we'll add material, it will get darker. So the way we're doing it now with the CAD model and making rapid prototypes is fantastic. We'll never be stuck with a Mark 7 because we have all our CAD designs perfected. So once we get our Mark 6, if the market doesn't like it, we will then go back. We can go back to our Mark 6, and as I get more feedback from people, we'll continually develop our product. So we're a bit unique in the market that I no longer believe in just copying the old stuff. I believe in improving it, because as I've worked with so many great players and gotten feedback, that just as I modified pieces, I figured out how to make them even better. So I've got an iPhone 6, and I no longer have my iPhone 3 or 2 because I think it just works better. And if we do something wrong, well, we'll just go back and then work off of that, which we do. And in fact, well, I should keep going here. So to talk just briefly about boundary layer effect, if you look inside the tenon, this is the tenon of our saxophone, you'll see kind of an inverse golf ball. And some of these designs happen by accident. We call it the super glue effect. I remember Matt was machining me a perfect golf ball shaped dimpled interior, and Matt was like, "Theo, the stock slipped inside and we got this." But I didn't really want to show it to you because you always like the mistakes.
And they got to figure out how to do it again.
Yes. And lo and behold, this was one of those times I was like, "Sorry, Matt, you got to figure out how to duplicate that." So I actually know how to make a better golf ball. Maybe we should do that. There's probably more money in that. So actually, the shape we're using inside the tenon sounds better than actually the regular dimpled shape. This shape we got from studying the hull of speedboats. And the idea, very simply, and I'll move on, right, is that these push the same amount of air. So it's each golf ball. In the beginning, golf balls were all smooth and round. They looked like a ping pong ball. And then they found the more they played the freaking golf ball, the farther it went. They're like, huh, why is that? Why is that? And then they found that the roughened surface created turbulence around it, which then sucked the air behind it, right? Which meant you then had to pull less air behind you. So it's not about pushing air, it's about pulling less, right? So it feels like, as a saxophone player, less resistance, right? So I'm designing this in many, many different ways into all of our products, saxophone and mouthpieces. And so if you look inside our mouthpieces, you'll see all these weird little things, and that's what that is. All right, medium chambers made famous by Autolink. Basically, a medium chamber is the bore and the chamber are approximately the same size. Made famous, again, by Meyer. Although Meyers really are closer to small chambers, but I'm not going to get into that for now. Small chamber is when the chamber goes significantly smaller than the bore. A good example of that's like a Selmer Super Session or the Soloist mouthpieces on soprano. The chamber gets really small, much smaller than the bore. And that's the definition of a small chamber. Right? And a small chamber gets you that kind of core sound, but it can feel kind of thin. And here's an example. High baffle small chamber. Bruce Springsteen there in the background. And that, as opposed to Jan Garbarek playing the Gaia tenor, right? That spread the sound, right? This is a very clean, focused sound, right? And that's generally the sound you get with a small chamber. Alto mouthpieces are a little bit different in design than tenor mouthpieces, so you can make them smaller and still get the same type of effects, but the general concept still holds true. So, the new Shiva mouthpiece was designed with trying to make the best of all these worlds, because no matter what mouthpiece I send Gerald, he's always like, can you make it even brighter? Can you make it even brighter? So I was like, okay. And so we took a Durga, made it even brighter, and it turned into the Shiva. And it's turned out to be incredibly popular. And so what I'm doing with the Shiva is I'm adding rollover to the baffle, high step baffle, and then a slightly smaller chamber. So it's our most powerful mouthpiece. I just recently also designed a mouthpiece with Mindy A. Bear. She's really letting go of that, that poppy thing. She's really getting into the rock and roll world. And check out her new album, Live in Seattle, which was recorded right here, and it's rocking. I mean, she's using the new mouthpiece we designed together, and it's like bright and powerful and edgy, but has just great expression to it. I'm really proud of it. So you could say that's kind of the Shiva version of our line right now. In fact, here's Mindy playing the Data, which was turned into the Shiva.
Here's CCR's Have You Ever Seen the Rain? With Philip Phillips.
Again, that bright projecting sound, but I wanted a faceted sound.
There's a calm before the storm, and I know it's been coming for some time. When it's over, so say.
So here's just a little piece. We made a whole document. I put it on the website yet. But a lot of the stuff I'm experimenting with. This sheet actually goes on and on and on. But I mentioned like the 3-point contact and light ligature. Pressure plates is a huge topic for me as well. This looks a lot like an Autolink, and it came about. I tried to make the Autolink shape better. Failed. It actually works the best. So I just accepted humbly that they knew what they were doing better than, I couldn't improve upon it really. So our pressure plates are shaped like an Autolink. We tried making it with the 2 grooves, you'll see, and that shape just worked the best. And some other manufacturers, like the Francois Louis, uses a thicker pressure plate that holds the reed on 2 points. But the problem is it still didn't allow the reed to vibrate as much as just using a thinner pressure plate with more contact. So that's why we have this shape. We have all these different materials, again, solid silver, titanium, heavy copper, vintified, stainless steel. I say titanium, anyway. With all these different pressure plates to experiment with. So our ligatures are designed to have a certain freedom because it's always easier to darken or take harmonics out. You can't go the other way. You cannot make a sound like this. But you can make this sound like a Rover. Does that make sense? Yeah. So we've got all kinds of little innovations here everywhere. The way I do double key arms here allows you to adjust the pad side to side, more instead of 2 key arms coming in, locks it in, so a repairman can't really adjust the key cut very well. This is the brace, octave key, which there's nothing soldered to the neck at all. Even the brace itself doesn't touch the neck right there. Allows the neck tube to vibrate freely. We have the first saxophone to ever use cartridge ball bearings. Which is cool. We're using different kinds of tip rail designs. This one's thicker in the middle than on the sides, which allows us to do interesting things with the baffle shape. So that's like on the Shiva mouthpiece has that. Again, different 3-step baffle, which was actually with a rounded inner sidewalls, which I patented a long time ago. We have, this is the reticulated finish that's on which is again like the golf ball that's been hit too many times and therefore goes further. The shark gill chamber, the inverted power ring, different window shapes, which all get a very different sound, so I hand-pick a window shape for each model. The Liberty ligature, which I already talked about, 4-point bell-to-body brace, which you can see on there. It basically replaces the 2 points here, replace the pants guard, right? So you'll notice there is no brace soldered onto the body tube. So there's less dampening that happens. You're just using these 2 points to basically hold the bell in place. Here's the first way I did the power ring on the Durga. This is the Durga 1, this is the Durga 2. This is a small chamber together with a large chamber. We're working with all kinds of new materials. In general, we didn't find anything that sounded better than vintage hard rubber. I told you we did that whole test with materials. And hard rubber, the vintage style hard rubber, sounded better. And the reason vintage rubber, we say vintage, is because back in the day it was the plastic. Like around the war area, 1940s, right? It was the new plastic. It was something stabler than wood, basically. In today's terms, it's extremely unstable compared to ABS plastic and urethanes, right? The sulfur and latex, natural latex that was in the hard rubber has incredibly good resonant properties. And the blue material we use right here is the only material we found that sounds better than hard rubber. It's actually far more resonant. And I'm not going to talk more about it, it's just a secret. And then here we have, like on the key guard of our saxophone, you can see I put the adjustment belts in line with the key arm. A standard saxophone has them off to the side, so when the key comes up, it actually twists the key cup. I was like, why would you do that? Just put them in line with the key arm. Right, shape. So it's just some of the little innovations we're working on.
What kind of material did Adolf Sax use?
Hard rubber. Oh, actually, no. What did it? Yeah, it would have been. No, wood. Yeah, the first ones were wood. Yes, wood. Yeah, the very first ones were all wood. Yes. All right. So, my last 2 little slides here.
I can't tell you how immeasurably powerful it is for me to know that I have the right tool for the job. And that when I know it and I'm in love with it, I don't even have to think about it. Then the expression, that is playing my saxophone happens. It's almost like there is no saxophone, there is no mouthpiece, there is no reed. I'm just saying what I need to say. That's where this stuff helps me get. So without you guys and your expertise and frankly raising the bar for the entire industry, I would still be in suffering. I mean, a 35
So we all need something to motivate us, right?
Or the only way I can get to that.
Like us in the mouthpiece we face.
You know, he's really, in his heart, he wants all of us to be the best musicians and the best artists we can be.
So, finish up here with a little bit. I mean, we are demonstrating products, so I have to throw a little bit in. So we get feedback, and please always feel free to give me negative feedback. My goal is to have all of you and everybody just feel inspired when you play the saxophone. I mean, I've got students all the time write us saying, you know, I used to practice, 2 hours a day. Now I practice 4 hours a day just because I love playing so much. That's the experience I want musicians to have. And the saxophone is such an expressive instrument. There's no reason why we can't have that experience. And so we'll just finish it with some of the feedback that we've gotten here.